Hello, I welcome you to the next tutorial for microwave-based non-destructive testing. Today we will learn about the NIDIT method, which presents the test results not pointwise, but directly as an image, as X-ray testing does. One of the most powerful methods of non-destructive testing is the X-ray through transmission. It is especially attractive because of its direct imaging, the high spatial resolution, and the capability for tomography. However, X-rays are ionizing and therefore harmful. Therefore, considerable and expensive safety measures are necessary and limit the use in practice. In case that the device under test is made from insulating, that is, dielectric material, and if the high spatial resolution is not necessary, then the microwave-based direct imaging technique NIDIT offers itself as an alternative. Microwaves are non-ionizing and therefore harmless. Please note, the use of mobile phones is only possible because the used microwaves are harmless. Here we see the basics of a NIDIT test setup. A microwave generator, for example at 24 GHz, and an antenna too, widespreadly irradiates the device under test. On its backside, there is a microwave absorbing foil. The microwave radiation, which is homogeneously incident on the front side, inside the DUT is affected by the defects and thus is inhomogeneously incident on the microwave absorbing foil. So the foil, according to the defects, gets a heat distribution which is detected by a heat camera 5 and displayed on a computer. The heat distribution corresponds to the defect distribution inside the device under test. In the following, we will see two example applications of the NIDIT method. Wind power rotor blades are made from two half parts consisting of GRP plates and balsa wood or foam. The two half parts are joined by gluing. After that, the distribution of the adhesive cannot be seen visually. It has to be tested through both or one of the half parts from outside. Here we will see a laboratory NIDIT test for this purpose. This photo shows the setup for the NIDIT test of a section of the trailing edge of a wind turbine rotor blade. This device under test has got an artificial distribution of the adhesive, and this distribution has to be detected from outside. Here we see the microwave generator and in black the horn antenna. The heat camera is behind the device under test. And on the back side, we see it here, of the DUT, the absorbing foil is placed. The sample is moved horizontally between the fixed antenna and the camera. Therefore, the sample is mounted on a moving stage. A thermal video is recorded, and in this test region that's approximately here, the DUT is approximately 200 millimeter thick. The video starts with the DUT and the absorbing foil here are outside the line of sight between antenna and camera. So we look into the antenna with the microwave generator in the background. The movement from left to right will be done 2 times with a vertical displacement between them. So let's look. I have picked out this screenshot to show the essentials. This wavy line clearly shows the artificial distribution of the adhesive. Quite surprising in this image is the square grid across the whole area. This stems from real thin plastic square grids which are inserted between the wood and the GRP sandwich layers of the half parts to improve their adhesion. The second NIDIT example shows the test of planks made from wood plastic composites, so-called WPC. Such planks, for example, are used as the ground floor of patios. Here we see 4 of such planks with thicknesses of about 23 millimeters. They were moved through the fixed NIDIT setup. To improve the sensitivity, this time a differential method was used. That is, each time 2 heat images of about 3 millimeter distance in moving direction were subtracted from each other, and the difference was displayed. Plank 1 has a wavy profiled surface and a non-visible crack inside. Let's look to the test result. This is the clear NIDIT image of the inside crack. Plank 2 has a plain surface and also a non-visible crack inside. Here we can clearly see the crack. Plank 3 has a profiled surface but no defects inside. As expected, no indication can be seen. Plank 4 has hollow chambers and the surface is profiled. This plank has defects. A few parasitic fillings of the hollow channels can be seen when looking into them from the ends. This is the video. a lot of indications of defects can be seen. We have learned about the NIDIT method. It uses thermal images to evaluate microwave test results. It is a transmission method. That means that both sides of the device under test have to be accessible. So far for today. Thank you for watching. See you next time. Goodbye.